Hello and welcome to Dr. T's ACT Prep. In this video, I'm going to go through this science test in 35 minutes or less. It's 1:29 p.m. and so we should be done by 2:04 if all goes well. Let's get into it. It says no calculator on this test, so we're back into the Stone Ages. Here we are. According to the scientist 2, friction between the rocks and the clay is reduced at which of the following? Let's look down here at scientist 2. Friction between the rocks and the clay. Looking for the word friction. Looking for the word friction. Presence of mud and clay. Begin to presence of mud and clay and the algae reduces friction. Presence of the mud and the clay reduces friction. Mud and algae. Sorry, algae. There we go. Suppose a researcher observed that the wind speeds greater than 80 miles per hour are needed to move the rocks in the plier. This observation is consistent with which of the scientist's explanations. So we're looking for the words 80 miles, rocks, and playa. 80 should be a giveaway. Here's playa. Fault line. Where else? 80, 80, 80. I don't see the word 80 anywhere. 80. Mud and algae. That's how we saw it. Needed to move. Wind speed is greater than 80 miles per hour. Due to the combination strong winds, combination of tectonic plate movement, strong winds, okay, and do we see anything about winds up here? Light winds. Yeah, so that's going to be scientists 2 and 3 only. Strong winds, strong winds. Suppose that no seismic activity was recorded in this playa where the trails left by the rocks are fallen. This finding would be weaken which of the scientists' explanations? No seismic activity. Okay, tectonic plates here, so probably not scientist 3. Oh, sorry. This scientist is saying, well, we're looking for no seismic activity. So this scientist is saying tectonic plate movement is important. Anything about tectonic plates here? I only see winds, wet surface. And then scientist 1, snowmelt. Temperatures rise again. Even light winds can push liftings, left and shallow only. So there's nothing about tectonic movement or seismic activity for researchers 1 and 2, so scientists 3 only. And suppose it were discovered that a particular rock formed a 200-meter long trail in 72 hours. Would this discovery support scientists' 200-meter long trail in 72 hours? Would it support scientist 1's explanation in 72 hours? Okay. When temperatures began to rise, leaving a layer of mud on the surface, ice rests around the rocks, the buoyancy of the ice rests float up in the rocks. Even light winds can push the rocks on the surface. Evidence of this listing is seen that the trails left by rocks are shallow and only about 2/3 wide of the rocks themselves. Due to the combination of ice, mud, and light winds, rocks were able to several hundred meters in a few days. Yes. So we're going to get rid of no and no. Yes, scientists 1 indicated the rocks can move 700 meters in a few hours. No, it said 700 meters in a few days. Suppose that during 1 year there was no measurable movement of any rocks in the playa during the spring. Scientists 1 and 2 would most likely both agree that this was due to the absence of which of the following? Algae, snow melt, strong winds, sub-zero temperature. So scientists 1 and 2 are going to mention the same thing. Algae, snow melt, strong winds, sub-zero temperature. Spring snow melt. Water to freeze. Rise again, ice begins to melt. Mud, or the answers again. Algae, snow melt, strong winds, sub-zero temperature. Scientist 1 said light winds. Scientist 2, if we recall, said strong winds. So Strong winds is not likely the answer. Okay, so snow melt is possible. Snow melt. Right there, snow melt does collect. However, the temperature does not get cold enough for ice to form. In addition to dormant algae and present in the dry clay begins to grow rapidly when the clay becomes wet. Presence of mud and algae. And then strong winds. Okay. Sub-zero temperatures. I think this scientist 2 is saying no sub-zero temperatures, so it's not that one. And then what? Most likely due to the absence of which of the following factors? Most likely we both agree that this was due to the absence. The absence of algae, presence of mud and algae, it says here, and ice rafts, rocks, trails, rocks, combination mud on the surface, lifting, temperatures begin to rise. Well, scientist 1 is not saying anything about algae, but they are likely to agree that the absence of snowmelt, ice begins to melt, doesn't say anything about snow. Snowmelt from the ground does collect in the playa, however the temperature of the playa does not get cold enough for ice to form. Would they agree about the absence of algae? I'm just going to go ahead and say it's snowmelt. Suppose that, they're running low on time already. Suppose that the air temperature in the playa varies between 4 and 47. Would this information support the explanation of scientist number 2? 0 degrees Celsius is freezing. Scientist 2 does say that it doesn't get cold enough to freeze, so we're in yes. Ice cannot form in that temperature range, and because ice can form in that temperature range, well, obviously we know that ice cannot form in that temperature range, and scientist 2 has said exactly that. It doesn't get cold enough for the ice to form. And then based on scientist 1's explanation, the rock trail that's 33 centimeters wide was most likely made by a rock within approximately what width? 33 centimeters wide, most likely made by a rock within, we're looking at scientist number 1. 2/3 as wide as the rocks themselves. And so 2/3 of 65 times 2/3 is going to be like 130 over 3, which is going to be greater than 40. So no, 50. 150 over 3 is approximately 30. It's close enough to 33, so that's our answer there. Next, tables and look at all these tables and things. I think it's best to go directly to the question so that we know what we're looking for. If another trial had been performed in experiment 2 and 450 milliliters of liquid had been measured in the cylinder, the temperature of the Diet Cola in this trial would likely have been, okay, we're looking at experiment 2, 450 milliliters, and then we want to know the temperature. Experiment number 2 is here. All right, the temperature of the Diet Cola was different in each scale. Again, if we were to do it again, and 450 milliliters of liquid had been measured in the cylinder, the temperature of the Diet Cola in this trial would have been 450 milliliters. So it's going to be less than that, which means our temperature is going to be, let's look at our, so temperature is going up as the volume is going down, so we're going to be greater than 60. Suppose trial 6 had been repeated, but the bottle of Diet Cola had been opened and left undisturbed at 25 degrees Celsius for 12 hours before it was attached to the apparatus. Would the mass of CO2 produced in this trial likely be greater than 0.969 or less than 0.969? Trial number 6. is in experiment 2. We're at 25 degrees Celsius, 25 degrees Celsius here. Okay, and so would the mass of CO2 produced in this be greater than or less than? Well, if a bottle of cola is open, then the CO2 should escape, right? And so I would just say, based on common sense, that some CO2 is going to escape and it's going to be less than. So I'm just going to get rid of these. And that, just because everybody knows, if you've drunk cola before, if you leave it out for 12 hours, you can get flatter. 1 millimole of CO2 has a mass of 0.044 grams. How many trials resulted in the production of at least 1 millimole of CO2? 0.044 grams. 0.044 grams. How many trials resulted in the production of more than? Well, all of them, right? So that's 1, 2, 3, 4, 5, 6, 7, 8. Yeah, that seems like almost a trick question. It's so easy. According to figure 1, which of the tube A and tube B, if either, had at least one end submerged in a liquid before the clamp was removed? Which had at least one end submerged in a liquid before? Well, we can see here, tube B. Next is the relationship between the volume of the liquid in the cylinder at the end of the experiment and the mass of CO2 produced directly. Relationship or an inverse relationship is the relationship between the volume of the liquid and the mass of CO2 directly related or inversely related. And it doesn't say which. Okay, so we're looking at volume. Volume here is variable. Oh, sorry, let's look at table 2. As volume decreased, the mass decreases, and so that's direct variation. The volume of liquid that was measured in the cylinder increased, the mass increased. Yeah, that's the exact same thing. Well, direct, they increase and decrease. That's not the definition of direct. Direct is increase, increase, or decrease, decrease. And so moving from trial 8 to trial number 1, the mass increases, and moving from trial 8 to trial 1, the volume increases, the mass increases. Next. 13, consider these steps that were performed in each trial, removing the clamp, measuring the so on and so forth. According to the procedure, these steps were performed in which sequence? All right, well, that's tricky. They give you 1, 2, 3, 4, and then they don't even give that as an option. Okay, we got to go look up here. Okay, the jar was filled. Is that removing the clamp, measuring the liquid, inserting it to attaching the tube. One holds the other end of the tube is placed in an empty graduated cylinder. A certain solid substance inserted into the tube. Inserting a solid substance into tube A. That's the first one. No. Okay, so it's going to go 3, and then what's after that? Either 4 or 1. 4, 1 attaching the tube, removing the clamp. So they insert the so on and so forth. They put the solid substance in there, and the substance was secured by a clamp. The clamp is next, which gives us B. Assume that room temperature is 25 degrees Celsius. In how many trials was the Diet Cola tested at temperature lower than the room temperature? Lower than the room temperature of 25 degrees Celsius. 1, 2, 1. At lower than 25 degrees Celsius is going to be And how many trials was the Diet-Cola tested lower than your temperature? Diet-Cola was different in each trial. And in how many trials was a Diet-Cola tested? Assume that room temperature is 25 degrees Celsius. And so it's trial number 5, but that's only one trial, so it's got to be F. Passage number 3. Okay, according to figure number 1, the nickel concentration of the nutrient solids increased. The average iron, figure number 3, is, where's figure 3? Sorry, figure 1, trial, passage 3. Here's figure 1, nickel concentration, looking at nickel concentration of the nutrient solids increased. The average iron concentration. So iron is the closed square and the closed triangle. The average iron concentration in the species M plants. So we see these two decrease as nickel concentration increases. We're just reading graphs, which means B. According to table 1, the species U plants that were fed the solution that had a pH of 6 and a nickel concentration of 10 micromoles had an average dry mass of. Species U plants were fed the solution that had a pH, species U, had a pH of 6. Species U, pH of 6. And a nickel concentration of 10, that's this one, had an average dry mass of, looks like 8.1. 8.1, okay. According to table 1, species M plants that were fed a nutrient solution in which of the following combination pH had the greatest average dry mass? Species M, greatest dry mass. Species M, greatest dry mass. Let's look, 33.9, 33.9. And what's our question here? According to species that were fed a nutrient, which of the following combinations of pH and nickel concentration had the greatest average dry mass? So we've got pH 7, nickel concentration 0, and pH 6, nickel concentration 0. And pH 7 is not an option, and so then our pH 6 is the only option available. According to table 1, figure 1, species M plants that were fed a solution 3 had an average zinc content of species M solution 3. So this is just like keeping stuff in mind and then referencing tables. Species M solution 3. Solution 3 is here. Species M. Solution 3 had an average zinc content. Zinc is not available in table number 1. Species M. Zinc concentration is the square. pH 7, nickel concentration. Oh, this is interesting. But solution 3 had an average zinc content of, we go from, let's look, we're at this open square, go from 100 to 400 over 50, a change in 15 in nickel concentration, which gives us, what, 100 to 200, change in 200, sorry, 300. Nickel concentration M, species M, 223.9. So let's look at our possible answers. Well, we didn't have an average of 100 or 400. That's pretty obvious. Fed solution 3. Solution 3. Oh my goodness. pH 7. Nickel concentration 10. Okay, there we are. That's why they give us solution 3, nickel concentration 10, and then that's 200 there. Wow. Okay. Yeah. According to Table 1 Figure 1, the species M plants that were fed solutions 1 through 4 in the order of nutrient solutions from the solution that resulted in the lowest average iron content from the solution that resulted in the highest average iron content. So we want to order them, species M, solutions 1 through 4 was the order of nutrient solutions from the lowest iron content to the high. So which solution had the highest average iron content to which solution had the lowest average iron content? Solutions 1 through 4, so we're in this top one here. And species M only. So it's 1, 2, 3, 4, nickel concentration, wow. The lowest average iron content to the highest average iron content. Average iron content is up here, iron, so we're at species M and iron, so it's closed square. So that was similar to the first question. We're trending downward here on this closed square box. So it's the lowest to the highest. What was the order of the nutrient solutions? The nutrient solutions. From low, okay, so the lowest is here and then the highest is here. So 4, 3, 2, 1. Okay. According to Table 1, compare the average dry mass of species U plants that were fed. Solution 3, the average dry mass of species M plants that were fed. Solution 6 was approximately the average dry mass of species U plants that were fed. Solution 3, the average dry mass of species M plants that were fed. Solution 6, U, solution 3, M, solution 6. U, solution 3, 10.7, M, solution 6, 23.8. 10.7 to 23.8 is what? 10.7, no, sorry, 28.8, sorry, solution 6, 28.8. 28.8, that's like 3 to 1, approximately 3 to 1. Oh my goodness, this is fast. Again, I recommend just kind of skipping through and look at the questions. If you practice enough, then that's... According to the experiment result, experiment 1, for any given catalyst, what's the temperature that was increased? The temperature cycles needed to complete the reaction. According to experiment 1, for any given catalyst, as the temperature was increased, the number of cycles needed to... As the temperature increased, the number of cycles needed to complete the reaction. In experiment number 1. Experiment number 1. Here we are, experiment 1. As the cycles increased, as the temperature increased, the number of cycles needed to complete the reaction. Well, you can see that this is a direct proportion. As the temperature goes up, the cycles goes up for any of the reactions, and so that's going to be increased only. Experiment 1, 26 cycles were needed to complete. So 26 cycles were needed to complete the reaction at 450 degrees, when which 26 and 450, so we're at 450 and 26, that's going to be catalyst X. Catalyst X, which is G. G. The movement of H2 and N2 through the apparatus in steps 1 through 4 occurred is best represented by which of the following expressions? The movement of H2 and N2 through the apparatus. H2, N2. So we go reactor pipe. Okay, so in each trial, steps 1 through 4 occur. Fresh catalyst placed in the reactor. Equilibrium established. Through pipe A. And then through pipe B. Reactor pipe A, condenser pipe B. Okay. Consider the experiment if 1 for 375 degrees. All H2 and N2 are consumed in less than 20 cycles. When which catalyst? So all less than. That's only going to be catalyst Z or Z, right? All H2 and N2, experiment number 1, all H2 and N2 all H2 and N2 were consumed in less than 20 cycles when which catalysts were used in less than 20 cycles? Less than 20 cycles. Here's our 20 cycles. All catalysts were consumed in less than 20 cycles. X, Y, and Z. Oh, 375, sorry. 375. Here we are. 375. And so it's all but W. All but W, J. If the trial had been performed in experiment 2 at 425 degrees and 2.25 atmospheres, the amount of NH3 produced would most likely have been 425 and 225. So we're at 225 and 425 gives us that one. The amount of NH3 would have most likely been NH3. What? 425. Oh, my goodness. I'm misreading it. Read the key, folks. Read the key. At how many degrees? At 425, and so we're between the square and the star. We're somewhere in here. Amount of NH3 at 225. So we're in between these two at 225. That gives us what? What are we asking here? I think that gives us star right there. And again, 425 is either star or closed square. And then star is like roughly 200 something ish. Yeah, there we are. So we're at 320. It's going to be somewhere in between here. At 1 atom of pressure, the melting point of NH3 is negative 77. The boiling point of NH3 is negative 33. Based on this information, the description of the apparatus when NH3 exited the condenser, was it most likely a liquid or a solid? So it's going to be liquid if it's between negative 77 and negative 33. It's going to be solid if it's less than negative 77. Where are we going to find that? I get temperatures of 300 to 350 here. Temperatures of 300 to 450 there. What does it say about that? Okay, negative 50, negative 50. Negative 50 is between negative 77 and negative 33, so we're going to get rid of the solids. And then because the temperature of the condenser was higher than the melting point and the boiling point, it doesn't make any sense, was between them. That's correct. Oh, I'm not going to make the time here, folks. I'm talking too much, and this is really quick. Considering the trial in experiment 2 that produced 550 kilograms of NH3 based on figure 1, the number of cycles that were most likely were needed to complete the reaction in this trial was most likely blank. 550, figure 1, the number of cycles that were needed to complete this reaction, 550 kilograms in experiment 2. So we're at this one here, meaning what the number of cycles based on figure 1, based on figure 1, 550, and so we're off in this unknown range here. The number of cycles for catalyst, does it tell us a catalyst? It does not. Oh, 550 kilograms. Oh my goodness. Figure 1, 150 for catalysts. At 550, where doesn't really tell us much of anything there. 550 kilograms is going to put us like right here at 150 such and suches. Oh my goodness. Based on figure 1, the number of cycles that were needed to complete the reaction in this trial. Figure 2, number of cycles needed to complete this reaction. Well, we can see that consider the trial and experiment 2 produced 550 kilograms. So that's 150 atom pressures, 300 degrees. Oh, okay, so there we are. 300 degrees, this open circle. And so that's going to be either less than 5 or between 5 and 10. I'm just going to go ahead and say less than 5. And we're running out of time, folks. Sorry. What's the approximate maximum alpha shown in figure 1 for 200 hertz sound wave with air at 10% relative humidity, and the approximately what temperature does the maximum occur? So we got 200 hertz, 10% relative humidity, temperature maximum. 200 hertz, 10%, 200 hertz, 10% relative humidity. What is the approximate maximum alpha for 200 hertz? Well, 200 hertz, the approximate maximum is like right there. And that's at 3 alpha, and relative humidity, 10%. At approximately what temperature does this maximum occur? It's like negative 5, 10, 15, 20, negative 5-ish. Based on figure number 2, the attenuation coefficient for a 1000 hertz sound wave on air, in air at 20 degrees Celsius, reaches a minimum value at relative humidity closest to which of the following? 1000 hertz, 20 degrees Celsius, 1000 hertz, 20 degrees Celsius. So we're at here, which is what, about just under 15. And that is alpha just under 15, which tells us what percent relative humidity, attenuation coefficient at 20 degrees Celsius, minimum value, sorry. So it reaches its minimum right in there, somewhere in there, around 30. I guess it keeps going here. Oh yeah, you can see that it climbs back up just a little bit, so we're in that region right there. Between 40 and 50 is 45. For the range temperatures and the range of relative humidity shown in figures 1 and 2 respectively, alpha for 200 Hertz sound wave, more strongly affected by changes in temperature or changes in relative humidity. So changes in temperature or changes in relative humidity for a 200 Hertz. 200 Hertz, we're going up and down for temperature and relative humidity. It's flat. It's pretty flat. And so we're going to say temperature. Get rid of relative humidity because maximum variation in alpha is about 0.5 decibels per kilometer in figure 1, but about 2.5. Well, figure 1, that would be the opposite. Again, so this temperature is correct, but then they flip-flop these two. Consider a 1000 Hertz sound wave at 10% relative humidity. At how many of the temperatures shown in figure 1 does alpha for this wave have a value of 18 decibels per kilometer? 1000 Hertz, 18 decibels per kilometer. We're here, which puts us at like 5 and 15-ish. For at how many temperatures? 2, right? Right or no? And how many temperatures shown in this alpha for this wave have a value of, oh no, of 18 decibels per kilometer. Oh yeah, and then we're over here too, sorry. There and there, so 4. Oh, we're way over time. Sorry, folks. Don't go talking to your page during the ACT. You're not gonna make time. Suppose that 2 sound waves, a 150 Hertz wave and a 1100 Hertz wave, are simultaneously emitted from a speaker into the air at 20 degrees Celsius, 45% relative humidity. Based on figure 2, as the wave travels away from the speaker, the intensity level at which the wave will have more likely decrease will more likely decrease at the greater rate due to attenuation. Suppose that 2 sound waves, a 150 Hertz wave and 1100 Hertz wave, are simultaneously emitted from a speaker in an air of 20 degrees. So we're at greater than, we can assume that the 1100 Hertz is going to do something like that, and the 150 Hertz is just going to be like down here. At 45% relative humidity, so we're in this. It's kind of like the flat line for all of them. And what are we going to say? What are we asking? As the waves travel farther from the intensity level of which wave will more likely decrease at a greater rate? Well, you can see the 1100 Hertz wave, that's like your treble. And this makes sense because treble, higher frequencies doesn't go as far. Lower frequencies move farther and because they move around and stuff. So the higher frequency is going to experience a greater rate of attenuation. So get rid of that, Because the A value is less than, or the A value is greater than. Well, the beginning A value here, the decibels per kilometer, is definitely greater for the higher frequency at the start. And then as the wave, as the relative humidity, I'm reading this incorrectly even. As the relative humidity increases, it says, it doesn't travel as far, which makes sense again because decibels per kilometer. The treble experiences more, impedance or something. A value is greater, well, that's just true. So you can see this A is just greater for this level is higher for these higher values here. Wow, the frequency graph below shows sound waves for 3 different frequencies, how A varies with relative humidity in the air temperature. Based on figure 1, particular air temperature is most likely which of the following. So we got 1100 moving up and going down. Based on figure 1, the particular air temperature, see 3 different frequencies of how A alpha varies. Which the particular air temperature is most likely which of the following. Well, at -20, we're all at the same point here. And they're definitely not the same. At 0, we're at, they're all increasing on their way to decreasing. Okay. At 20, they're all decreasing here. And at 100, they're decreasing again. Particular air temperature is most likely which of the following. So going up and then down. It's kind of on the slow trend line down, flatlining. I mean, I would say either 0 or 100. Zero. Almost there. Wow, that was... So old folks need extra time, and I think young folks should probably get extra time too. 35 minutes? That's nuts. In study 1, as the ratio of fructose to glucose in the sweetener solutions increased, the amount of sweetener solution consumed per rat per day. So glucose and fructose increased, and the amount of sweetener consumed. I'm guessing it's going to go up. Just a guess. Haven't looked at it. Study 1, glucose and fructose increase. Sweetener, mass glucose. Food solid, amount consumed per day. So glucose so as sweetener decreased, solid food consumption increased. I was wrong. Decreased only. I guess they feel fuller when there's more sugar in their food, so they would reduce the amount consumed. That also makes sense. In study 1, the amount of sweetener solution consumed daily by each rat could be measured because which of the following steps have been taken? The rat's access to food. Study 1, the amount of sweetener solution consumed daily by each rat could be measured, but which of the following steps taken? The rat's access to solid food had been restricted. The rat's access to solid food had not been restricted. Well, restricting their food isn't going to help this study because we want to know how much they'll eat depending on the amount of sweetener in the food. So we just want to have them. It doesn't help measure it anyway. If you put them in the same cage, you can't measure how much each individual rat is eating. But if you put them in different cages, then you can measure how much they're eating individually. And then there might be a control group and an experiment group, and that would be like restricted and not restricted, and you can compare them or something. That's a separate issue. Suppose a sweetener composed of 46% fructose and 60% had a mass tested based on table 1. Study the ghrelin concentration per sample. Okay, so Study 3, Table 1, Study 3, 46%, 54% ghrelin. Okay, 46% fructose. That's going to be closest to R. Ghrelin, like a felon. And so yeah, I'm going to go ahead and save that one because it's either G or H, but since we see here 4258 is actually slightly less fructose and slightly more glucose than we're looking for, it's going to be between R and S. It's going to be slightly more than R, slightly less than S for fructose, slightly less than S. Sorry, slightly less than R, slightly more than S for glucose, and which would put us between R and S here. Consider the claim. Okay. The group of rats that consumed the lowest amount of solid food per day was also the group that had the lowest concentration of leptin per sample. Do the results in Study 1 and Study 2 support the claim? The group of rats that consumed the lowest amount of solid food per rat per day was also the group that had the lowest concentration of leptin. Well, in Study 1, they didn't study leptin, they studied sugar. And the group that consumed the least was the group that had the most sugar. But let's look at Study 2. Leptin seems to be directly correlated with glucose and inversely correlated to fructose. So sweetener, the type of sweetener affected how much leptin. But the amount of solid food consumed did not then correlate to the leptin, but moreover just the amount of sweetener solution. Oh, wait. Fructose. Okay. Oh my goodness. Sweetener solution. Okay. So, my bad. So the rats consumed more of Q than they consumed of U. And so they consumed the glucose. They preferred the glucose over the fructose. And so glucose, more leptin, fructose, less leptin. And so they consumed more. Let's see, the lowest concentration of leptin, no, this is definitely a no answer. Rats in group 1 consumed the lowest amount of solid food per rat per day, but the group 5 had the lowest concentration of leptin. Let's see, is that true? Lowest concentration of leptin, highest concentration of the lowest concentrated, but the rats in group 5 had the lowest concentration. No, consumed the lowest amount of solid food, but the rats in group 1. Rats in group 1 consumed the lowest amount of solid food. Correct. And they had the highest leptin. Correct. Oh, sorry, lowest. Group 5, okay, yeah, so correct. Group 5 had the lowest concentration of leptin, and group 1 consumed the lowest amount of food. Wow. Which of the following groups of rats, you dirty rat, should have been studied in Study 1 to serve control for consuming a sweetener solution on the consumption of solid foods? Which of the following groups of rats should have been included in study 1 to serve as a control for the effect of consuming a sweetener solution on the consumption of solid foods. A group of rats that had access to, so this is more like a methodology question or experimental methodology question rather than something you can look at the tables for. Only water. If you don't give them food, you're not going to have a very long study. Only solid food. Yeah, I'm just having trouble visualizing that. Neither water nor solid food, you're really not going to have rats for very long there. Well, you should have controlled the whole sweetener solution deal by just giving them regular food and water, right? Right? So only water and solid food. Consider the sweetener that resulted in a solid food consumption of 16 grams per rat per day in study 1. Based on table 1, how many grams of fructose would be present in 200 grams of this sweetener? Study 1, 16 grams per rat, 200 grams of sweetener. 200 grams, 16 grams per rat, 200 grams of sweetener. Solid food consumption 16, that's going to be group 3, sweetener S. How many grams of fructose would be present in 200 grams of this sweetener? 200 grams, 50-50, so we're at sweetener S, 50%, and 50%, if it's 200 grams of that sweetener, then it's 100 grams of fructose. And the experimental designs of study 2 and 3 are identical with respect to the factors listed below. The chemical indicators. Chemical indicator that was used, the hormone with which the chemical indicators was used. The chemical indicator. Okay, studies 2 and 3. Well, they use different indicators, leptin and ghrelin. Oh, sorry, indicator P. No, different indicators, indicator N and indicator P, and then they had different hormones, leptin and ghrelin. And I think you just have to infer that leptin and ghrelin are hormones, which requires outside knowledge of neither one or two. And that is the ACT science test done way too slowly by a 45-year-old math teacher. But you get the main idea. Don't talk during your ACT, folks. And you got to work fast through these things. Pick up on the keywords. Scroll through tables. My recommendation is that you flip back and forth between questions. Don't spend your time looking at the, reading each word and then going to the questions. I recommend going directly to the questions, finding your key information, and then flipping back and forth between the tables and the questions in fast-paced mode, in beast mode, as it were, if you want to do really well in your ACT science. All right, this has been Dr. T's ACT Prep. Thank you.